Hello, we created a solar heater and our objective is to demonstrate that using a parabola as a mirror you can heat a sausage with the solar heat and also with the exact calculations of the parabola. And now we're going to give you a brief explanation of what are the four conics. The circumference is the locus of points on the plane that are equidistant to a fixed point called center. By this, I mean that the circumference is the exterior line that covers the circle, and the center is located in the middle of the circle.
An ellipse is a set of all points in a plane such that the sum of the distances from two distinct fixed points called foci. The line that crosses the center to one of the points of the ellipse is called major axis, and the minor axis is perpendicular to the major axis, and 2 points at this ellipse are called vertex. Parabola is a set of points x and y in a plane that are equidistant from a fixed line called the directrix and a fixed point called the focus. The point between the focus and the directrix is called vertex. The latus rectum crosses the focus. The directrix is the line the same as the focus but in negative.
A hyperbola is the set of all points such as that the difference of the distances between and two distinct points is a constant. The foci are the points found inside the curved lines. The asymptotes are the imaginary lines that never touches the curved lines. The center is the midpoint of the transverse axis, and the vertices are the points where the curved lines and the transverse axis touches.
Well, now we're going to show you our methodology. So first we have to create the parabola and we measure the length of the box, which was 33 centimeters. So that's the length from here to here. And then we located the focus at 5 centimeters because the height of the box is 11 centimeters, but we left 1 centimeter for the base. So from here to here are 10 centimeters, which is this. Yep.
Then what we do is that we cut the shoebox with the shape of the parabola, which is this one, and we cut it all the edge, well, all this front face and the other, because we need to place the solar here, which we made with this thing, which is cardboard covered with aluminum foil, which we cut it at the same width of the box, so we can place it that fits right there. So later, with the solar energy or solar rays, it will serve as a solar heater. And when we placed with these two things we put here, the focus, which is right here, it will receive all the heat because it acts like a mirror. And as you can see, the whole sausage is like receiving all the heat, and so it cooks. And that's our final result.
Okay, so we are going to measure the cooking time of the sausage, and our controls will be putting the experiment in 45 degrees so the sun can heat more the sausage. Also, we are going to check it every 10 minutes to see how the experiment is going. And we are trying to put the experiment always in a part when the sun can really heat the experiment, because maybe the clouds can cover the sun. And at the end, to see the total time it takes to totally heat the sausage.
Well, now we have our final result. And if you look closer, you can see that our sausage is a little bit burned. So it took around an hour to get like this, but comparing it to our expectations, we thought that it was gonna get a little more cooked, but it didn't. So we thought that maybe what went wrong was that it didn't get like the correct amount of sun, and that's why it is not that well cooked. But we believe that our project did work, but not as we will want it to. But this is what we get.
Now, for concluding with this experiment, we're going to take back some important points about it. First of all, we previously mentioned about the experiment. This solar heater had a parabola shape which caused a mirror effect, and by this it made that the focus, which is the center of the parabola, which is this here, caused that the sausage started heating. And for this we noticed that obtaining the heat wasn't the best way to do it, because we failed in some calculations, but we can say that it really had a great impact on the final result, because the sausage did really burn a little bit, but it was okay. And it is really important to have all the precise data and equations and measures.
To measure all of the, well, all of the data we do for the parabola, of course, what we first do is to to measure all of this part. It's not the diameter, but it's like, well, the length, for example. Then we needed to focus. Well, this is the lactus rectum, which is, let me see, it's um the lactus rectum. Then we had to focus all of the, well, the center, which is not the center, the focus, and that's it.